All right, page 5 of the review packet starts with exponential and logarithmic functions. And so the first example here is evaluating an exponential function 2 to the e. This is really just a calculator question. All right, so if I raise 2 to the e power, right, this e doesn't have a power. So we're going to, it's implied that it's power of 1. So I'm going to do 2 to the e to the first on the calculator, and I get 6.50580885991. Okay, so let's make sure we round this correctly. So if we wanted just 4 decimals, okay, the 4th decimal place is an 8, and so we'd look at the one after it, and if it's greater than 5, we're going to round that 4th decimal place up, okay. So since the 5th decimal is also an 8, we need to round that 8 up, and so we get 6.5809, okay. So not too bad, all right. Then we're evaluating logarithms, right? So we have log base 25 of 5 equals x. So remember what we do, right? We want to cancel the logarithm and write it in the exponential form. So what I like to do is just raise both sides by the same base. So we have log base 25. So I'm going to raise both sides by 25. Okay, and 25 to the log 25 will cancel. And I get 5 equals 25 to the x, all right? So here's where you have to remember what the powers do, okay? So what power do we need to raise 25 to get to 5, right? We know if we divide 25 by 5, we'll get 5, but there's another way, okay? And so what that is, we also know that the square root of 25 is 5, all right? So if the square root, remember, is the same thing as 25 to the 1/2 power, right? So here the answer would be 1/2. Okay, so let's go ahead and do the same thing on the next one. What if we had log base 3 of 27 equals x? So first things first, I want to cancel the log. So I'm going to raise it by an exponential of the same base. 3 raised to the log base 3 cancels. And I get 27 equals 3 to the x power. Well, what power of 3 would get you 27? Okay, I believe it's 3 cubed, right? So since 3 cubed equals 27, then we know this exponent must be 3, okay? So make sure you can evaluate logarithms. So the next two are expanding the logarithm. So we're going to use those laws of logarithms. So if we have a product, a quotient, or a power in here, we're going to expand those out. So first things first, we have u cubed times v squared. So we have a product inside our argument. So I can write this as log, I'm not sure if I meant 9 there or a, but let's go with 9, okay? Log 9 of u cubed plus log 9 of v squared, all right? So we're going to separate that product into 2 distinct logarithms, right? So then what we can do, what we need to remember to do, is if we have a power, those powers can be pulled out front, right? So the cube is going to come out front as a 3. So we're going to get 3 log base 9 of u plus, and then the squared can come out front as a 2, so we'll get 2 log base 9 of v. And this is fully expanded, because if you look in the argument, there is no products, there is no more quotients, and there is no more powers, all right? So if you might want to put a note for yourself there. No products, quotients, or powers in the arguments. Right, that's how we know it's fully expanded. All right, so here we have a fraction and we have products everywhere, okay, and we have one power here. So make sure you're splitting this up in the right order, right? The first thing is we have this quotient that is encompassing, we have a product up top and a product down below. So what you want to do is you want to split up this quotient first. So we're going to get log of x times x plus 2 minus log of 5 times x plus 3 squared, right? Split up that quotient. All right, now inside these two logarithms, we have a product, and a power, right? So we need to split up this argument one step farther, right? So I'm going to split up this product into two separate logarithms. So I'm going to get log of x plus log of x plus 2, right? Minus, now here I have a 5, an x plus 3, and a square, right? You need to split up this product first. This is 5 times x plus 3 squared. And only the x plus 3 is being squared, right? If you brought the 2 out in front and then split it up, it's like you're saying the 5 needs to be squared and the x plus 3 needs to be squared. And that would be incorrect, all right? So we need to do log of 5 plus log of x plus 3 squared. Now there's a mistake here, right? Because when I split up this product, I have a minus sign in front of it. And so that minus sign, both of these terms needs to be in the denominator. So I need to put log 5 plus log x plus 3 squared in parentheses so that this negative sign can get distributed, and then both of those arguments can be put in the denominator. All right, one more step, guys. I'm going to go ahead and distribute that negative sign, and I'm going to bring this 2 out front. I'm going to go ahead and finally take care of that power, right? So the final expanded form is log x plus log x plus 2 minus log 5 minus 2 log x plus 3, right? Final expanded form, right? We have 2 positive terms and 2 negative terms because we had 2 terms up top and 2 terms down below, right? And that square is only applied to the x plus 3, okay, not to the 5 as well. So be real careful there. Now, just as a review, right, this logarithm doesn't have a base. So it's understood, right, to be base 10. Don't forget, okay, a log without a base is base 10. All right, so we had a base 9 on the first example and a base 10 on the second example. All right, the next 2 problems, we're going to condense these logarithms. So we're going to go backwards, all right? So it's how do you add or subtract logarithms. But first, before we tackle that, we have these coefficients. So remember, the numbers out in front are really the powers, right? So I'm going to pull these numbers back and write them as a power. So I'm going to put A on this one. It's kind of hard to tell the difference between A and 9, but let's do A. All right, so if I pull that 2 back, it's going to square everything inside that parenthesis. So on this one, the 5 is squared, okay, and also the x plus 3. So we're gonna simplify this in a moment, right? Minus the 1/2 power gets pulled back, and so remember what a 1/2 power is, right? It's a square root. So I'm gonna skip the middleman there, and I'm just gonna write it as a square root, okay? So now what I need to do is I need to subtract these logarithms. How do you subtract logarithms? I hope you can answer that question, right? How do you subtract logarithms? You divide the arguments. So I'm going to write one logarithm. I'm going to write a fraction. This positive one divided by this negative log. So as I do that, I'm going to go ahead and square this, okay? What's 5x cubed times 5x cubed, right? 25x to the 6th, correct? Right? So we're going to get 25x to the 6th divided by the square root of 2x minus 3. Okay, this is fully condensed because we got everything into one logarithm. All right, so let's do the next one. First things first, pull those powers back. Okay, so the 3 is going to become a cube. The 2 is going to become a square. So we get log base 5 of 3x plus 1 cubed minus log base 5 of 2x minus 1 squared. And then again, how do you subtract logarithms? You divide arguments. So we're going to get 1 logarithm here, and I'm going to put the 3x plus 1 cubed on top of the 2x minus 1 squared. Right? It is not necessary to multiply this out unless it's easy, like 5x cubed times 5x cubed. Right? You don't have to do a whole bunch of foiling in these questions. All right, so condensing, get them into 1 logarithm, right, correctly. All right, here we go. Solving a logarithmic equation. You just had a test over this. You must be able to solve a logarithmic equation, right? So we have log x plus log x minus 21 equals 2. We need to cancel this logarithm, but before we do that, we've got to combine these, okay? We need to add these logarithms together. So the way we add logarithms together, right, is we multiply the arguments. Okay, so I'm going to combine the 2 logs together. So if I multiply x times x minus 21, I'm going to get x squared minus 21x, right? So you have to get them into 1 logarithm before you can cancel. Now, we need to cancel the log. So we need to raise it by the exponential of the same base. So if we have a log with no base, right, it's understood to be base 10. We just went over that, right? So I'm going to raise both sides by 10. 10 is going to cancel the log, and I'm left with x squared minus 21x equals 10 squared, right? So I get x squared minus 21x, basically equaling 100. Here's my quadratic that I need to solve. And the way you solve a quadratic is you set it equal to 0. Okay, bring this 100 over first. Make sure it's set equal to 0 before you start solving. Okay, so x squared minus 21x minus 100. This should factor. If it doesn't factor, you can use the quadratic formula. Okay, what multiplies to negative 100 and adds to negative 21? 25 and 4, right? So the 25 should be negative, and the 4 should be positive. And so we get x minus 25 and x plus 4. Set each factor equal to 0. And we get x equals 25 and x equals negative 4. Now remember, with logarithms, not every solution is an answer. Okay, we have to make sure it's in the domain of the function. So you need to check these. Okay, so the first answer, 25, does that work? Well, if I plug it into the original, does everything remain positive? Okay, log of 25 is positive. 25 minus 21 is positive, right? This one checks out. Okay, but what about negative 4? If I plug negative 4 into the first one, then I get a log of a negative number, and we can't do that. And then if I plug negative 4 in the second one, we have another log of a negative. Okay, so this negative 4 is not a solution. So make sure you're checking your answer, right? Because I guarantee you there is going to be an option of an answer negative 4 and 25. Okay, and then there's going to be an answer just negative 4, an answer just 25, or an answer of some off-the-wall factor. Okay, so when you're choosing these multiple choice answers, make sure you're really double checking that you are indeed correct. Right. All right, solving exponential equations. Make sure you remember all that. Okay, but that should be easy. Wasn't that long ago. All right, so for the algebra portion, I gave you a copy of this page, but obviously those of you in college algebra, we're not going to do this trig stuff, okay? So just do the top portion here, all right? So in the graph transformations, I'm going to give you a function and I'm going to ask you what certain numbers do. Is it a shift up or down? Is it a shift left or right? Is it a vertical stretch or a compression, horizontal stretch or compression? Right? So remember try and remember those graph transformations. So if we had a function and we added a constant to it, right? This would be a shift up C units. Right? So, I don't know, let's say, for example, I had the square root of x plus 1 minus 3. Okay, and I said, what does the negative 3 do? Right? Does it shift it up? Does it shift it down? Does it shift it right? Does it shift it left? Okay, I want you to make sure that you know, right? So the negative 3 is on the outside, so this will indeed shift it down. Shift down 3, right? Okay. Transformation, direction, and units. All right. So if we put the c inside the function, if this is indeed plus c, remember the plus moves in the opposite direction. So a plus c would shift this back to the left. All right. So this is going to shift left C units, right? So if I had the same function here, what does the plus 1 do? Excuse my writing there. What does the plus 1 do? Okay, up, down, left, right. So this is positive, right? So it's going to shift to the left. So shift left 1. All right. So then let's put a constant out in front. Okay, so I'm going to have a constant a times f of x. If it's multiplied on the outside, this is a vertical stretch or compression, right? So a, let's treat this as a whole number. Okay, so if a is greater than 1, this is going to stretch vertically by a. But if a is a fraction, let's just go ahead and go over it, right? If it's a fraction or a number between 0 and 1, it's going to compress vertically by a. Right. So in this function here, I went ahead and added a 1/3 out in front, right? So now my a is 1/3. So since it's between 0 and 1, this is going to compress vertically by 1/3. So if I asked, what does the 1/3 do? You're going to compress vertically by 1/3. Okay. And then the A on the inside, that is our horizontal stretch or compression, but they also work in the opposite direction. And I'm pretty sure the algebra textbook didn't cover this. So this review is more for my pre-calc students. Okay, so I'm not going to worry about that. So if you can just remember your shifting up, down, left, right, and vertical stretches and compressions. No, we did two. We did two do this. Let's go ahead and do this. All right. If A is greater than 1, we're going to compress horizontally by a factor of the reciprocal. And if A is between 0 and 1, we're going to stretch horizontally by the reciprocal. Okay, so remember that the horizontal stretches and compressions move in the opposite as the vertical ones, and the factors are also reciprocated. So let's just take, for example, this one. Okay, we have the square root of 2x, right? So the base function here is actually the square root of x, right? And the 2 is on the inside. So that's going to stretch or compress horizontally, because inside is horizontal. And since it's greater than 1, it's actually going to compress horizontally by 1/2, all right? So compress horizontally by 1/2, right? And so if we were to draw this, remember we had our original, okay? And if I were to compress it horizontally, that means I'm going to shove it towards the y-axis there. So if I shove this graph towards the y-axis, it's going to get taller. All right. So there's what's going to happen. Here we have 1/3 x. So say the base function was x squared. We have a 1/3 on the inside here. Okay. So since 1/3 is between 0 and 1, this is going to stretch horizontally. And the factor is the reciprocal. Right? So if the factor is 1/3, the reciprocal is 3. Right? So what happens if we stretch horizontally? Let's take an x squared and stretch it. Okay? So we're gonna pull it away from the y-axis. So if I pull this away from the y-axis, I get something that looks like that. All right? You don't have to worry about the trig functions over here, but stretching it. Okay? All right. What's kind of interesting here is if I were to multiply this out, if I were actually going to square x over 3, I would get x squared over 9. And so by doing that, I'm dropping those parentheses. So I'm getting 1/9 times x squared. And in this form, there's no longer a horizontal transformation because now 1/9 is being multiplied times the base function x squared. 1/9 is on the outside. So what's going to happen here is this is a vertical stretch or compression. And since the a value on the outside is between 0 and 1, this is going to compress vertically by 1/9. Right? But what happens when you compress a parabola vertically? Right? You shove down on it. And when you shove down on it, it gets wider. So both the horizontal stretch and the vertical compression do the same thing to our base function, which is really kind of interesting. All right. So there you go, college algebra students. There is your algebra review for the final. Now I am going to send out an extra document with topics and problem numbers from the book that you can also look at. All right, this right here is not an exact replica of the final by any means. It's just hitting all the topics with a sample problem. All right, so good luck studying.